Today we're in a tech tip session on pointers and punchlines, mastering embedded C. This is from Embeetle. If you have not checked out the Embeetle IDE, you should do that. You can go over to embeetle.com. With us today is Kristof Mulier, who is not only an embedded C god, but he's also the co-founder of the Embeetle IDE, and he's going to be walking us through a couple of things, but I did need to make an update based on the amount of content we have. So this is all based off of the embedded C tutorial that Embeetle put out. There's so much content, we were going through it, and we wanted to be able to fit this into a reasonable amount of time today. So we left out the parts about arrays and strings. We do have an addendum. So we're going to be uploading the slides so you can take a look at those. They're at the very back of the presentation, obviously. But that means that today's mostly going to be focused on pointers. So we're going to be doing a lot around pointers, data pointers. We're going to have some examples and then go into pointer arithmetic. There'll hopefully be a little bit of time at the end for you to go through some questions with Kristof. He's also a member of the DevHeads Discord server. So I'm putting in a link to the DevHeads Discord server in the chat, so please check that out. If you have questions for Kristof or any of our other embedded and IoT technology experts, you can join us over there. And so specifically C around variables, characters, functions, anything around C, Kristof is your guy, and you're going to want to try to learn all that stuff through the Embeetle IDE. So check us out over at DevHeads, and this is going to be a pretty awesome presentation. I'm really excited. Kristof's a good friend, and he's really knowledgeable on this topic, so you're in for a treat. I do need to go over through a couple of housekeeping items before we begin. So I just want to make sure that you're aware that you're inside of the DevHeads Meetup platform right now. And if you want to head over to the chat interface, it's the big white box that's to the right of your screen. And if you don't have a big white box to the right of your screen, there's a little icon in the bottom menu navigation called chat. Click that and you'll end up in the chat, and that's where we can all talk today. So if you have questions for Kristof, throw them in the chat and we'll get to them at the end. If you just want to talk to the other participants who are in the audience today, that's where you do it. So there are a bunch of other menu items down at the very bottom, and they take you to different things. I did mention that we're going to be having some handouts, like basically the slide presentations. I'm going to throw those into the handout section. So if you go over to apps in the bottom nav, click handouts, they'll end up there. I'll push those up there when we get into the presentation, and I'll send them a note in the chat to let you guys know that it's there. The questions tab is another place you can throw questions into. Don't feel obliged because I'm going to be monitoring the chat as well. So just wherever suits your fancy, just put your questions and messages in there. And also, if you're on Facebook, LinkedIn, YouTube, any of the other destinations that we're streaming to right now, use the chat function that's native to that platform. I'll go around, and the other members of the team will go around and monitor that occasionally and make sure that we grab your questions and bring them back in here so that Kristof can answer. One of the things that if you run into problems, if you can't hear anything, if you can't see anything, there's a good chance it's your internet connection. Go to speedtest.net. If you're pulling less than 5 megabits per second down, you're going to have a problem streaming. So just be cautious of that. And then any other like browser related issues or anything, if you're inside of the Meetup platform, go over to the help button, which is in the bottom left of the platform. And that'll take you basically through a wizard that'll ask you to test and solve all your potential issues. So that should get you back and up and running in no time. So without further ado, we're going to go ahead and get started. I'll add a bunch more information about DevHeads, the Discord server, which has about 2,300 members in it right now. Head over there for more help. And some of the other interesting background information that Kristof and I have created over the last year or so. Tons of resources for you. But I don't want to take up any more time because you guys didn't join to hear about how webcast platforms worked. You came here to learn about C. And as I pointed out, arrays and strings are going to be sort of on the back burner today, mostly about pointers. And Kristof, why don't you introduce yourself?
Yeah, so as you can see, I'm a hardware and software developer. I studied at KU Leuven University I studied electronics engineering. I worked into analog digital electronic circuit design, embedded software, and that's how I rolled into the startup Embeetle to build a better IDE for microcontrollers.
Great. So now pointers and data pointers straight from the Embeetle pointers and punchlines presentation and the Embeetle C programming tutorial. So Kristof, I'm going to let you take it away. So you got those directional arrows there on your side to push the slides. And yeah, from here, the floor is yours.
So what I'm going to present here is a chapter of the book, Pointers and Punchlines. And I had the privilege to give a 2 weeks course about this at the SUSTech University in Shenzhen. So here we're going to focus just on a single chapter from the book. And let's get started. So as you probably already know, if you have some experience with embedded software, is that a data pointer holds the address of another variable. So you can see it here on the screen. Pointer P is holding the address of variable X. And in this particular case, the address is just a hexadecimal number of 16 bits. But depending on what kind of microcontroller you're working on, it can be a 32-bit address or whatever. Anyway, let's go to the next slide. What this slide is all about is about this dereference operator, the star operator that you saw in the previous slide. This star operator, that's actually the thing you have to really keep in mind when you're working with pointers. When the star operator is not there, then the pointer is not dereferenced. Okay. When the star operator is there, it's dereferenced. Then you're not working with the pointer variable itself, but with the thing it's pointing at. So the problem is that this dereference operator is quite mysterious. It's not always clear in what case, when you see the dereference operator, if the pointer is really dereferenced or not. But we're going to check all the situations. So actually, it's a context-dependent operator, and that's what makes it a bit tricky. So we're going to look at all the contexts that you can be interacting with a pointer: declaration and definition, initialization, and use of the pointer. And in all these contexts, we will see what this dereference operator, the star operator, is really doing. So by going through all of these contexts, we will make sure that we're not getting confused. So I'll skip to the next slide because I think this one is clearer. When you are declaring or defining a variable, then the dereference operator is not dereferencing at that very moment. The only thing it's doing is that it's basically saying what you see there on the display. It's saying, like, if you would dereference P, then that would give you an integer. That would result in an integer. So at that moment, you're not the star operator is not actually dereferencing. It's just stating what would happen if you dereference the P, the pointer. So let's now look at the next thing that happens after a declaration and a definition of a variable. It's the initialization of the variable. You're giving it a value. And there you see there's no dereference operator in front of the P. The P is just there without anything, right? And you're assigning to P the address of x, the ampersand character, it's the address of character operator. So let's see what happens here is in the initialization phase, you're taking pointer p without the star operator, without the reference operator, and you're assigning the address of x to it. So what you're doing is you're putting the address of x in the variable p itself. Okay. So we've covered declaration, definition, initialization. Now it's time to look at the last phase, which is to use the pointer, right? So you can use the pointer in two ways, not dereferenced and dereferenced, okay? Not dereferenced means you're not putting the star operator there. You're operating on the pointer variable itself. So that's what we're going to do here. We have pointer p pointing at x. So p is holding the address of x, the address of x being 0x001c. And then we are going to add 3 to pointer p. What we see is that we are actually increasing the address being held by pointer p. So pointer p is no longer pointing at x, it's pointing at something else. Okay, so this operation is not doing anything on variable x, it's just making pointer p to point at something else, something further up the memory. Now, with the star operator, it's an entirely different situation. With the star operator, we are not operating on the variable p itself. We are dereferencing p. And this is where the word dereferencing, the word that I've been using the past 10 minutes, really gets its full meaning. We're dereferencing p, which means that the actual operation is on x. That's what p is referencing at. Okay, it's x. So x used to be 42, and now it's 45, because you're adding 3 to it. Right? So this is a little overview how this star operator can either, when you put it there, how it dereferences the pointer. That's basically it. Now here is a nice overview, a summary of all the different contexts in which you can encounter a pointer. So we have seen the context of declaration and definition. If you're just declaring and or defining a pointer variable, then the star operator is not dereferencing the pointer. It's just stating a fact. It's stating that if you would dereference it, then you would get a certain result. In all other contexts, the star operator will perform the dereference. And then you have to be careful. If you're assigning, like in the initialization phase, if you're actually assigning an address to the pointer, then you don't put the star operator. If you want to operate on the variable you're pointing at, then you have to put the star operator. I think this summary is really important. Maybe you can print it, hang it on your wall when you're working with C code, because this will help you to not get confused with pointers. And here's a little comic, because we have so much information to absorb. It's also nice to have a bit of a laugh. So it's what this comic is saying is that the dereference operator, what you can see here is the dereference operator the star operator will dereference pointer p to look like x. That's what you see on the first page. But then on the second page, you see that in some other contexts, like when the p is getting born, when it's getting out of its egg, the declaration and definition phase, then the star operator is not really dereferencing, it's just stating a fact. That's what this comic is all about. And it's also a warning, because if you dereference a pointer before you initialized it properly, it can point at anything and anywhere in the memory, and then you are in for disaster. Like this. Mixed contexts. So sometimes the context in which you're using a pointer is not very clear. Is it, like, for example, this? Is this a declaration definition or an initialization? Well, it's actually both. You're defining and you're initializing at the same time. So this is a mixed context. Well, then you can ask this question. Is the star operator dereferencing here anything, yes or no? Well, you can split it up in two pieces, this mixed context. And sorry for the slide, the accolades, they moved up a little. But what you can see here is that the first part, everything before the equal sign, that's the definition, which also fulfills the role of declaration. It's the definition of pointer p, right? So there, because it's a definition, you put the star operator there, not to dereference anything, but just to be part of the definition and defining basically that p is a pointer of a type of a pointer type. The second part, everything on the right side of the equal sign, is the actual initialization. So, well, you can see on the right side, I've split it up, the mixed context, into a clear definition and a clear initialization. Okay, let's go through a few examples. I have a very nice example here. We have some code on the left. And on the right side, we have a RAM memory of a supposedly 16-bit microcontroller, right? And here we go. We execute the first two lines, and there we define first variables x and y. Okay, variable x and y get an address, and they have their own location in the RAM memory, and in the beginning they're all 0, or can be any, we just suppose they are 0. Then second line, we define pointer p as a type pointer to integer. Pointer p gets also its own address in the RAM memory. Now we are giving certain values to x and y. We give the value café to x and beef to y. Okay, this is a little jokey trick, because these are hexadecimal numbers and you can use 0 to 9 and A to F in constructing your hexadecimal number, so we can form a few words, right? But it doesn't really matter, we're just giving some values to x and y. Now on this line, what we're doing here is we are assigning the address of x to pointer p. And note that in this initialization of the pointer p, we are not putting the star sign, okay? Because we want the address of x to really go into pointer p, which is a variable in itself. So we want this variable pointer p to hold the address of x. That's what you see very clearly happening here. If you look at pointer p in the memory, pointer p is also a variable by itself. It holds now the address of variable x, right? On this line, we are now dereferencing pointer p. We are putting the star sign there. Okay, we're dereferencing pointer p, and then we are modifying it. We're doing something. We are changing its value. Now notice how the actual value change happens not on p, but on x, what p is pointing at. Okay, that's the whole point of pointers. What is happening right here. Now we are giving pointer p the address of y, and then we're doing the same thing. We're going to modify the value of y. Okay. Now we're going for the next section, pointer arithmetics. So we've seen a few slides before that you can increase the address held by pointer. For example, you increase the address held by pointer p by 3. So what does that actually mean? Well, naively, you could think if you take pointer p, which has, for example, value 1c, and you add 3 to it, that you get value 1f. That would be like the naive approach. But that's not happening. What's really happening is that the compiler will check the pointer type and then apply the proper arithmetics. In other words, if pointer p is of type int, integer, and suppose that we're working on a 16-bit microcontroller, which typically has integers being 2 bytes long, then what's really going to happen if you increase pointer p by 3 is that you are actually increasing it by 3 multiplied by 2. Okay. Now, I want to say something about integer. On a 16-bit microcontroller, an integer is typically just 2 bytes, 16 bits. On a 32-bit microcontroller, an integer is typically 4 bytes, being 32 bits. But even this is not always clear. So the size of an integer, that's a whole chapter by itself. Okay, but we're not going to dive into that. The point I wanted to make here is about pointer arithmetics, how they really work. Okay, so the pointer arithmetic system, if you're incrementing or decrementing a pointer, you actually modify the value by multiples of the size, the number of bytes, that of the type that the pointer points at. So if I have a pointer pointing at an integer of 2 bytes, then every pointer increment will be in steps of 2. If the pointer is pointing at something else that's, for example, 8 bytes in size, then every step will be 8 bytes. Okay. Another interesting thing to consider is what does p point at after you increment its address. So take, for example, pointer p when it was pointing at integer x, and then you increment it a few times, and now you're wondering, what is it pointing at? What does it see? Well, maybe in this particular, if you look at the the slide, you see there on the address 0x0022, you see there two characters, A and B, because maybe that's what you've written there before. Now, because the pointer P, it's of type integer, this particular pointer is of type integer, it will just, when it looks at that address, it will just see bare bits. Okay, so it will just see the bits over there, and then it will give its own interpretation to those bits, right? It doesn't care that you put characters A and B in that position. What it cares about is it meets a few bits and it gives its own interpretation. And what's its own interpretation? Well, this particular pointer is of type int, so it will interpret the bits over there as being an integer. Okay, if this pointer would be of type float or double, then it would give those bits an entirely different interpretation, right? So that's also something you always have to keep in mind. What type of pointer am I working with? Because the raw bits that are in my memory will be interpreted this way or another way, depending on the type of pointer you're working with. Yep. Moving through arrays, that's what pointers are perfect for. Because if you think back about pointer arithmetics, take, for example, an integer pointer. If you increase the pointer address by 1, as you know from the pointer arithmetics, it will actually increase by 2 if you're working with a 16-bit microcontroller with 16-bit integers, such that you land on the next integer. So if you want to move through an array, this is just perfect because every pointer increment will give you the next element in the array. Okay. But you have to watch out when you are moving through an array. As you can see in this little comic, it's about Bobby. And Bobby is having a lecture from his father, warning him that if he is jumping and moving around through an array, he must not leave the bounds. Because if he leaves the bounds, he goes into unknown territory. And if he's then dereferenced, that's what you see there, that's a disaster. Okay, you don't want that to happen. Okay, so Bobby promises to his father to be careful and to stay within the bounds of the array. The thing is, in C code, you have to do that yourself. You are responsible to make sure that your pointers stay within the bounds of the array they are moving in. It's not very safe. I mean, you have to make sure yourself that what you're doing is safe. Right, so Brandon, are you there? Because I think we are at the end of this chapter.
Yep, I'm here. Can you hear me?
Yep, loud and clear.
Yeah, great. All right. Well, awesome stuff there. No, I think pointers are really one of the first things that you get to when you're beginning your journey through C programming, where things start getting another level of complexity, right? Like you get to arrays and strings and stuff, and all of that is it's not easy, but it's very you can understand it. But then when you get to pointers and you start getting into dealing with memory is when things get tricky. And honestly, this is where people start making a lot of critical mistakes, right? This is where it's like this is where errors occur. So that's one of the reasons that we selected this particular topic today. One of the things that I wanted to know, Kristof, is from your perspective, just to get like the conversation sort of going here, where do you see, where do you see the most opportunity for there to be mistakes? Like, where do people usually accidentally, input errors and have bugs that introduce bugs into their programs?
Good question. I think the whole tricky thing of this dereference operator, the star sign, it behaves depending on the context. So you have to be very mindful, I would say, about when you see this star operator. In what context are you at that moment? Are you declaring the pointer or defining the pointer? Or maybe both, because declaration and definition can happen on the same line. Or are you initializing the pointer? Or are you using the pointer? So it depends on the context, and that's what makes it so hard. So that's why I have this little overview. I can go back a few slides. Yeah, yep, got it. This overview, I think that's where most mistakes are made. So you have to be mindful, okay, what context am I working in here? Such that you know what the star operating at that moment is really doing. Is it dereferencing, yes or no? That's what you need to know.
Yep, for sure. A couple of questions coming in now. The first one is, can you explain what a narrowing integer is?
Sorry?
It says narrowing integer.
What is narrowing integer? I'm not sure if that's a thing, narrowing integer.
Yeah,
but
Vashu. So, sorry, go ahead, Kristof.
Maybe what he was worried about is when I show these slides here with an integer being only 2 bytes. That's because in my slides, I've based my slides on an old 16-bit microcontroller. And on this 16-bit microcontroller, an integer is just 2 bytes. Now, on modern 32-bit microcontrollers, integers are mostly 4 bytes or 32 bits. The thing is that the real size of an integer is something you cannot, how to say, it can depend from one processor to another, from one compiler to another. Okay, so when you're talking about the size of an integer, if you really want to be sure, then you have to use the uint or int underscore t, and then 8 or 16 or 32. I don't know if I can write it down somewhere here on the slide.
Yeah.
I can write it down in the chat. I can write it down in the chat.
Yeah, why don't you do that? And meanwhile, what I'm going to do, Kristof, is I'm going to share something from over in Stack Overflow that I think is what he was referring to. So basically, when you're trying to move an integer, from bigger to smaller or smaller to bigger, this is referred to, sometimes as narrowing or widening. And I think that is what Vashu's referring to, is that sometimes when you do this, you can get data loss. So I think that this is what he may have been talking about.
Data loss. Data loss happens if your integers are too small to contain certain numbers, or if you're adding up numbers and the result is overflowing and cannot fit into the resulting integer. Then you have to use casting. So you cast the integers to a higher level. For example, 32-bit or 64-bit. So yeah, that's what you're seeing here on the Stack Overflow side. And I'm going to see, maybe I can send you guys a from our own web page, an image about casting.
Do you know? Yeah, if you can tell me, I can navigate over to
Yeah,
Embeetle, which,
yeah,
by
yeah.
the way,
That's
does.
that's just a moment. Typecast. Uh, hmm.
Oh, the Copilot's here already. Nice.
Mm.
So while Kristof's looking, guys, so one of the great things about Embeetle is that it's designed exclusively for microcontrollers. So a lot of the stuff that Kristof's been talking about here is really important when you're trying to write code for microcontrollers where you've got constrained resources.
I have here a web page. Let me share it here, and then you have to go to chapter 8, typecast operator.
Okay. So maybe we'll do another one on operators in the future. But all right, here you go, Kristof.
Yeah, so you see there, well, it's a slightly different situation, but you have two integers and you're going to do some arithmetic on them, and you could lose some data because you actually want to end up with a float. And you have to cast both integers to floating point type to make sure that you don't lose any data. Right.
So Vashu added over in the chat, he's doing bit manipulation of adding two 8-bit values to get 16-bit value.
Bitfields.
Yeah.
Okay, Bitfields. I think that's a terrific topic, a wonderful topic for a next session, because Bitfields, we do have very interesting material on that. So if I'll share with you the web page. Let me share it in the chat. So here's the web page on Bitfields. Can you open it, Brendan?
Yep, I'm getting to it now.
Super.
Here we go.
Yeah, Bitfields. Yeah, so Bitfields, it's a whole topic by itself. I can't just explain that in few minutes. I think we really need to take our time for this in another session. But it's certainly something extremely useful in embedded software, because you typically have these registers that you have to manipulate certain bit fields from to get certain things done. That's what this is all about.
That's great. So yeah, that's definitely one that we'll bring up later. Ranjith, I see your question, but we've got a couple over in the questions tab that I need to get to because they've been there for a minute. So Asafal is asking here about two mysteries of pointers: void pointers and forward declaration. He's struggling to understand the difference between void pointers, or not the difference, but struggling to understand them in general. So why don't we start with void pointers? Can you talk about those for a second?
Void pointers. It's a long time ago I've used void pointers. I would have to look it up myself. It's too long time ago.
Sure, no problem.
Sorry.
No problem. What about forward declaration?
Forward declaration. Oh, right. So that's actually when I mention about variables, you can declare and define a variable. it's also something many people mix up. So it's in our I'll show you on our website where this topic is getting attention, and I'll send you the link. Can you please go to that link? It's our webpage on variables. Okay, wonderful. So please scroll a bit down, and maybe all the way down to overview. Yeah, so there what you see is, okay, let's ignore weak definition and tentative definition in this overview, because otherwise it's going to be too complex. But what you see is on the left you have this concept of declaration, a pure declaration. You're declaring variable foo, and on the right side in strong definition you are defining variable foo. The difference is that when you are declaring the variable, you are merely mentioning to the compiler that this variable exists. While when you are defining the variable, you are doing something more on top of that. You're not just saying to the compiler this variable exists, you're also assigning a memory space for it. You're allocating memory space for the variable. And maybe if you scroll up and you go to chapter 4, I think there is, to chapter 4. Yeah, you got it there. So there, basically, what you see there is the difference between declaration and definition, right? And declaration is something you can do, like what I think Vashu said, like forward declaration, so that you can do the definition later on. And this is also very handy when you are using header files, because you can put the pure declaration in the header files, and then you include the header files in several C files, and then in the C files you can use these declared variables, but you have to make sure they're only defined in one of them. I think, yeah, there is a nice comic about this. If you scroll a little down, a little more, yeah, show comic, that one. I think that one gives, this comic shows you the difference between declaration and definition. Yeah, just take your time to read it.
This is great. Great. Yeah. So some really good. So go ahead, Kristof.
Mm-hmm.
Well done. So Ritesh just joined. Right now we're in the Q&A, Ritesh. We're talking about, we're answering questions. There was just a question that came through from Asraful that was talking about a couple of things that gave him some problems, one of which was forward declaration, and Kristof just went through what forward declaration was. There's another one over here, Kristof, over in the questions tab, talking about, and I'm going to move this into the chat just because there's some code here and I want to make sure that everybody can see it together. So here it is. So Batis says, oh, he always comes across this kind of pointer code when dealing with ARM registers and doesn't fully understand how it works. What are they assigning the pointer for in this case? Because there's not a variable. There is no variable. Very specific. So I don't know if on the fly this is maybe a little bit tough for you.
No, I can say something about it. It has to do with well, this number 0x20010000, that's most probably the address of a specific register of the microcontroller. And what you're doing is you're assigning a pointer and giving it the address of that specific register. And then in the second line, you are giving it a value. So you're writing a value to that address in memory. It's a bit of a trick, and I understand it's very hard to process this as a human. But if we would do the session on Bitfields, then this will become clear. If you open the web page on Bitfields, then I'll send you again the link.
Thanks.
If you open that web page again.
Here you go.
Okay. So if you move down a bit, more and more, and then Bitfield use cases. Let me check. Bitfield syntax. Sorry, it's chapter 4 on that page. Sorry, you have to scroll down quite a bit. My apologies. Chapter 4. Yeah, chapter 4. And then if you scroll down, then you see for example, this specific trick that that you mentioned in the chat, where a pointer is used to manipulate a specific register in the microcontroller. And this chapter explains how that works, how this little trick works. If you go down, then you see, how, and you see usually the keyword volatile is also added over there, and so forth and so forth. So it's quite complex material, but this is where you need to be to understand that dirty trick ARM is applying. Yeah, this is the page.
Great. He's got a follow-up coming. And then after his follow-up, I do remember that there was another question. And Vashu, you read the comic from left to right. Sorry about that. Let's see. We've got a couple other questions from Vashu, but I want to make sure that we get ABX in here as a follow-up so we don't keep bouncing around. And meanwhile, Vashu is explaining to Taj that
hello. I lost connection for a moment. I'm very sorry. Can you repeat, Brandon?
Sure.
Sorry.
Yeah. No, you're gaining fans. Okay, I thought that he was going to follow up with another question, but he was just saying how much he loved you guys, which he should. So Vashu notes that I think that this is in response to one of the questions that was earlier from Osrafol, which was that void pointers. Vashu notes that for void pointers can store any type, any data type of pointer. I'm not sure.
Yeah. I remember I used void pointers a long time ago, but I didn't use them that much, and I must admit that I forgot.
Yeah, no worries. But he goes on to explain that if you do malloc, it returns a void pointer in C, and if you have to type past into your required data type pointer, you need.
Yeah. Right.
Okay, let's see. Any other questions that we have in the chat or in the questions tab? It looks like we've gotten through pretty much everything. But if you do have questions, obviously, as you can. Oh, sorry, Ranjith. I think I skipped you. Let's see if I can go locate that original questions. What are the uses of null pointers, Kristof?
Okay. Can you repeat, because my internet connection again got
Sure.
my apologies. Yeah.
No problem. What are the uses of null pointers?
Null pointers.
Yeah.
It just means that the pointer has not been initialized, or you give it value null, 0, and you certainly don't use it if it's still being null. I mean, you're not going to dereference the pointer and do something with it, because then you have absolutely no idea what is going on.
Yep. There's a question here that says just says size of pointers ? I don't know if you.
Size of pointer. Normally the pointer itself is on a 32-bit microcontroller. It's just 32 bits wide. On a 16-bit microcontroller, it's 16 bits wide. Usually, and of course the size of the thing it's pointing at, that can be anything. It depends on the type of the pointer. But the pointer itself is usually like 16 bits or 32 bits, depending on your microcontroller.
Great. There was a question about the arrays and strings material in here, and we got to wrap up here in a second, but I just wanted to let everybody know that if you go into the bottom navigation, if you're in the Meetup chat or in the Meetup platform, there's an icon that says apps. Click apps, and then there'll be a menu that's revealed, and then click handouts. Once you click handouts, there's going to be a new window, and then it's going to have a PDF of the presentation slides. At the very end, there's an addendum, and I moved all of the slides or the arrays and strings information into the addendum because I wanted to make sure we had plenty of time to go through pointers today. But you can check those out. And yeah, if you have any other questions or need any help with those, there are a couple of different resources that you can go to. And I'm going to take back over control of the slides here. So, whoops, I'm jumping straight into those things right now. All right. So the additional resources. So obviously, if you head over to Embeetle.com, you can check out more about their IDE, which is free to download, great for using with microcontrollers. And then I also put a link in here to the overall tutorial. So this is the whole thing, right? So you can navigate through it yourself, and you can find whatever you need. And then Kristof and I a while ago did an overview of embedded memory. So a lot of the stuff that's covered in this quick video, it's like 12 or 13 minutes long, is a lot of what leads up to this point in the embedded C tutorial. So it's going to give you a good understanding of like embedded memory and how that works and how you would navigate it and some of the challenges you might encounter and how to overcome them. And then, of course, if you have if you need more information or help on some of these things, just like some day-to-day stuff, you can check us out in the DevEds Discord community. So you can either go to deveds.io, that's the website, or you can go to discord.gg/deveds. Key thing here is the chat. Use the chat and you will more than likely get some help pretty quickly from people like Kristof, who've been doing this for a long time and are a wealth of knowledge. So you might as well take advantage of them. So I'm going to put these links back into the chat real quick, and hopefully you guys all got a lot out of today's session. Vashu's asking when the next session on C will happen, and I think that's something that me and Kristof have to talk about and get on the schedule, but we could probably do it relatively quickly. I know it's a busy time of year for everybody, but we'll definitely let you know. Keep an eye out in the Discord community, and you'll see when or on the website, and you'll see when that session pops up on Bitfields, because it looks like that's going to be the next thing that we talk about.
Yeah, Bitfields.
Yep, Bitfields.
Love that. Yeah.
Really quickly, a couple other sessions that are coming up here on Friday. Zach Osiemo, if those of you who've been following what we've been doing around real-time operating systems, is going to be discussing the Zephyr device tree and motor control applications. So that'll be cool. And then the next day on Saturday, hack session with Wilson, talking about three-phase BLDC motor control. So a couple of things that you won't want to miss if you're into those type of applications. And then here's another comic on the way out. I'm an embedded developer. What's that? It means I'm afraid of the heap. No, it doesn't. Stop, Patrick. You're scaring him. So we are really fortunate to have people like Kristof in the community. Thanks so much, Kristof. It was awesome. Always good to talk to you, my friend. And for the rest of you, good luck developing, and we'll see you in the community. Have a good rest of your day.
Thank you.
See you guys.
See you. Bye-bye.